So we're going to do a couple things today. The test is ready. I'll talk to you about that at the end of class. We're just missing what, Ryan? So he's usually here, so we'll get started this way. Actually, you know what? I don't think I need to share the screen, not right away. So we talked about thunderstorms. Okay, so let's just go through stuff that you should know in your life. So thunderstorms are, what are the three types of thunderstorms?
Single cell, multi-cell, supercell.
Okay, and what makes a supercell a supercell?
Vertical wind shear. Or rotation.
Rotation. What is that area of rotation called? Shannon? Here, everybody keep their mics on because it's going to be like really fast stuff. So Aaron, scream out if you know it and you want to say it. What's the area of rotation in a supercell called? Sam, I know you know it.
Yeah, I just don't want to.
Julia?
I want to let other people.
Is it the mesocyclone?
It's the mesocyclone, right? And if it's not a mesocyclone, it's a supercell. So that's something that we look for. Supercells are going to be most likely severe. What is the criteria for severe thunderstorms? One of three things, and only those three things. Number one is?
Wasn't it hail greater than an inch?
Greater than an inch. That's about the size of a quarter. Wind?
Over 50 knots.
Over 50 knots, like 58 miles an hour. And then tornadoes. Those are the three things. And what are the three ingredients for thunderstorms?
Lift, moisture, and instability.
And then once I have lift, moisture, and instability, and I get thunderstorms, what makes them either single cell or multi-cell or supercell? The amount of what?
Wind shear.
The amount of wind shear, the vertical wind shear. Okay, so I have a class that's entirely in that. Lena, you took that class. Which of the two classes did you think is harder?
I almost felt like this one was harder.
Sam, what do you think? Intro or severe weather harder?
Well,
There's Ryan.
I'd say intro because
It is
it covers things that aren't within my expertise.
Right. Which do you think was more work, Lena?
Severe and unusual weather.
That's usually how I tell people. I'm a little bit more lenient on the grades, but then I think this class is just harder stuff because things don't always connect to each other. Like radiation is completely different. We don't do radiation in the other class at all. The parts of the atmosphere, we talk about global warming, the greenhouse effect, ozone, that kind of stuff is big. So
I agree, and hurricanes aren't very much similar at all to thunderstorms.
Right, that's true. Hey, speaking of hurricanes, we also did the hurricane chapter. So do me a favor and open up your book to page 205, because this is kind of where we were. So if you've got your book, Isaac, you got your book?
Yeah.
Okay. Kevin and Aaron, you got your book?
Yeah.
Okay. So on the hurricane, we just want to do the basic parts of the hurricane. Obviously, the most famous part is the eye. And then the thunderstorms that surround the eye are called the eye wall. Okay, and notice that they're kind of surrounding the eye. And they have the eye making a cone like this. It's what we call the stadium effect of the eye, that it kind of comes out like this. It's not a big deal. Those are the biggest storms. Then we've got spiral rain bands that go into it. So you can see some of the spiral bands over on page in the picture on 205 at the top. Sometimes storms have, say,
Would we have to know that the strongest winds are in the inner part of the eye wall?
the inner part of the eye, that's where it is. Yeah, we'll talk about what you're going to need to know for the test. It is, what's the most deadly part of a hurricane?
Storm surge.
Well, here, the storm surge, right? It's the water, it's the ocean water's coming in. We showed that video. Did you like that video the other day? Julia, did you watch it? That's kind of cool. That coming in that's the most deadly because it kills people pretty quickly. However, if you're inland, away from the shore, what's the most deadly part of the storm? Or what kills a lot of people?
The wind.
No, the wind doesn't kill that many people. I mean, yeah, there's things that happen, but
When it hits
really the
land, that's when it would most likely kill people from wind.
well, but
You got
wind's
that
not,
northeast quadrant of wind. That's where it's strongest.
yeah, it's strong winds, but wind doesn't usually kill people as much as this other threat. Aaron, you know the answer?
She says floods.
Flooding, right? It's the rainfall, it's the flooding inland. That's the stuff that's really bad. Okay, so that's just something you ought to know. Let's go to page, well, I guess that's it. Let's go to the chapter 13. We talk about forecasting, and notice in there they go prognostic equations, right? And if you look at the prognostic equations, prognosis is what's happening. I mean, it's what's forecast to happen. Diagnosis is what's happening. So prognosis, look at the first one they mention in equation 13.1. What's that equation?
Newton's second law of motion.
That's Newton's second law of motion, right? F equals ma. So that's really the big thing. You accelerate, you change the velocity, and then if I know the force is acting on it, then I know how the air is going to change its motion. And that's how I basically can do a forecast. And it talks a little bit about grids. I think you just kind of look at that. Did I have you outline this stuff?
No.
No? Okay. So we're not going to go too much in there, but Sam, this is some stuff in there for forecasting that might be worth looking at. And then chapter 14, I think we did a few pages on chapter 14. With climate change. Then what I really want to do last with you guys is go back through the book and then go through a quiz. So go to page, well, we can start on page 168. We have your four basic air mass types are, and you should know these: MP, MT, CT, and CP. For us here in Illinois, the Midwest, the two most important ones are the maritime tropical, the warm, humid air coming up from the Gulf, which we haven't had much of this spring, and then the cold, dry air mass coming out of Canada, which we've been socked into a lot.
Doesn't even look like we'll have much of it in the coming weeks.
You don't. Yes, you will. I'll show you. I'll go through a forecast with you. Maritime polar starts to come in from the Pacific. Sometimes that's when the jet stream is west to east, or basically zonal. Then we can get some of that maritime polar air mass. It's usually cool, and kind of cloudy. We don't get continental tropical very often. We don't get that hot air from the desert Southwest. Okay, and then we talked about the fronts, the four types of fronts you should know about. Page 171, there is your Norwegian wave cyclone that goes through the occlusion. Incipient, the word incipient means like birthing, like just about to happen. So we get the approach of a shortwave trough helps get cyclogenesis. So incipient means it's going to be born, cyclogenesis, creating that. Then it deepens, it's mature, and then it occludes. And really the strongest low is usually about a day after the occlusion. There's some cross sections of fronts that we've talked about. The other day we talked about the T-boat model, which is whatever. It's just another way of kind of thinking about it. Page 173, when we have lows that deepen, and this is a result of baroclinity. Just remember the difference between baroclinic and barotropic. A baroclinic wave tends to slant to the west. So figure 10.9, the upper level low pressure slants to the west. If you occlude and you're wrapped in cold air, the low becomes what we call vertically stacked. Or vertically aligned, they say, but stacked or aligned. Okay, then we talked, there's areas of convergence and divergence within the trough and the jet stream. And we talked about divergence, etc. And then I like the picture on the next page, on page 174, because it kind of shows you that upper level flow pattern and what the air is doing. Because remember, we did the cyclonic, and then it goes over the wave, and then it diverges coming down. Okay. When it occludes, it gets cold core low, it goes to 175. Then they give you an example of a cyclone. They just kind of talk about it, where the snow is. We mentioned a lot of this stuff. This is a good illustration of things. And then I'm not going to worry about southern hemisphere because it's upside down. So I'm pretty comfortable going through the book that we have. I think that, did you guys like the assignments coming out of the book? So last semester, Lena, you did outlining for the units. And then this one we're answering what was better.
I like the questions more, and not even because it was like quicker, or it just made you like look for specific details, which I liked.
Did you guys feel okay with all of that stuff?
Mhm.
You want to give me some feedback on that, Julia? What are you thinking?
I thought it was good because like there were specific questions. So like if you just said take notes on chapter 13, I feel like I might have skipped over things that were important. So this way, like you kind of gave us what we needed, and then we were able to look for it.
Good. And did you like the weekly assignments?
Mm-hmm.
I think that's pretty good. I like the fact that you did a chapter, maybe 2 a week, as opposed to saying you have 5 chapters over the next 4 weeks. Just kind of paces you along. How is the workload overall in this class?
I don't think it was that bad. Like a chapter a week, and then sometimes like a quiz or a test over the weekend. I didn't think it was terrible. I thought it was pretty good.
I really wish that we had, if you were in class, you'd have to study more for the test. I think that's what I don't like about online open note tests. Are you studying for the test?
Oh, yeah.
Well, you guys are? Okay. Because I know some of you probably don't. Like, it's open note, I'll just do it, right? What did you think about the tests?
The tests were fine.
Okay. Hey, Ryan, are you there?
Yeah, sorry, I just have to do it off my phone.
Oh, okay. What did you think of the test, buddy?
Yeah, I thought it was fine. You know, I understand you have to, you know, it's online, so especially when it's online, you're almost kind of expected to go to the next level, and you really have to understand it and
Yeah.
get more than just kind of surface level knowledge.
The test coming up, since you're all here, it's primarily going to be on the stuff through the wind systems. And then I have 15 questions, I think, on the low with the fronts, and I ask you questions about the weather associated with the cyclone. So it's really mostly on the wind system. A lot of the stuff on thunderstorms and hurricanes, I don't think I've even asked you questions. It's fine. You guys are taking notes on it. That's not that hard. It's the beginning part of this unit. But I'm not going to put a time limit on the test, so you have plenty of time to go find what you need on that stuff. And that's your last test. So do you see your grades so far? Are you content with the grade that you have as it currently is?
Yeah.
I think those grades right now are pretty good. Some of you might move up, but I don't think I'm going to move anyone down from where you are. So just keep that in mind. All right, let me do this. Let me share the screen because I want to do a little bit of stuff with you today. The first thing is take out the physics worksheet. Physics lab. Because I want to make sure that we have the right answers to that, since that's kind of important. So let me go here. Physics. I don't want the physics lab, I want the physics. You have a big truck at your place, Shannon?
Oh, this construction, sorry.
Okay, so you see this sheet, right? Here's my Epic pen. Epic pen. All right, so first thing is, what's the Bayes-Ballot law?
The wind to your back, low pressure will be to your left.
Right? Low pressures to your left. And the same would be true if I said, hold on, what's wrong here? Close. Okay, so low pressure, or you could say low heights. There's a region of low, here, listen to this. Low pressure at the same height is the same thing as low heights at the same pressure. So if they're isobars, we draw isobars on horizontal surfaces. Everything's the same height. But if we're drawing iso heights, then everything's the same pressure. So those two are like that. Okay, so low pressure is on horizontal surfaces. Low heights would be isobaric. Remember? So hopefully you got that right. I don't know where my Epic pen control is. Oh well, we'll just have to leave it this. All right, what's the forces of gradient wind in a ridge? In a trough, pressure gradient force always points from high to low. Coriolis force is always opposite the winds that you know from the Bayes-Ballot law. And then centrifugal force is outward. So in a trough, PGF equals CF plus centri. But if I'm in a ridge, then what reverses are the direction of these, and therefore the centrifugal force comes on that side. So in this one, it's going to be centri plus PGF equals CF. Okay? And I have to get control of my pen. It's like the pen exists without my controls. Don't know why. Okay, there we go. Friction acts what?
Opposite to the direction of motion.
And deflects air across the isobars toward
Lower pressure.
lower pressure, right? It's always making the pressure gradient force win. Because remember, when I've got these forces, oh gosh, what is wrong? Epic pen toolbar, where is it? I don't see my Epic pen toolbar. I think there's a problem with something in Epic pen. I'm sorry, guys, this is just annoying. Okay, so we're here. So I need to erase that, and I've erased it. All right. So what was I saying? We said know how to fix this. See, it's like it's not letting me draw. Now it, as soon as it does that, and I open it, it's like it's still in memory. And now I can. This is so annoying. All right, let's try this. I think I can do it this way, yeah. So pressure gradient force, what's the formula for the pressure gradient force? What's the formula? What's the Coriolis course? Hey. Okay, so what I'm saying is when friction comes in here, it slows the wind down, right? Well, which of these forces is dependent on velocity? Well, that one and that one. So these two forces get smaller. This force will then be unbalanced in both those cases. So because they're unbalanced, the air will always go toward low pressure. Remember, air wants to travel low pressure. It's not because of the Coriolis force. But once I get rid of those two forces, it actually does what it's supposed to do. Okay? Now, what force acts outward? That's easy. But you should have said more than century. What should it be? What's the full word?
Centrifugal.
Centrifugal, right? Now, what if I had said, what force points inward? What force points inward? What would you say?
Centripetal.
Centripetal. That's inward. 2. Okay. What's omega refer to physically?
It refers to the rotational frequency of the Earth.
Rotational frequency of the Earth. Don't tell me its value, but now I'm asking you, what's the value? You remember?
Is it 7.292 times 10 to the negative 5th?
What's the unit?
Per seconds.
Right? S to the -1, because it is a frequency. All right. What are the 4 different size scales? You should know this. What's the smallest?
Micro.
Micro next.
Meso.
Then next.
Synoptic.
And then the last one.
Global.
Global scale. What are some examples of them? What are some micro scale?
Like turbulence.
Turbulence. Maybe this is what about mesoscale?
Thunderstorms and like a sea breeze.
Thunderstorms, sea breeze. And in other words, the Coriolis force is not that important. What's synoptic scale?
Cyclones, anticyclones, short waves, fronts.
Good. Those are the four that you need to know. Did you get them all? Cyclones, anticyclones, short waves, and fronts. And then macro scale would be what?
Be Rossby long waves.
Oh,
Mhm.
dude, right? So you'd say long waves. I thought that's what you were going to say in the jet stream. And then I was going to ask you, what's the technical name for a long wave? And then Zach already said it, Rossby waves. So that would be what you need to know, okay? Geostrophic wind vector. What's the geostrophic wind vector in this one? Remember, you're just drawing a vector representing the wind. So it would be this way, right? Parallel to the isobars with the bi-spat law. Notice that the south is lower pressure. So some of you got this. I'm not sure if everybody did. The difference between a vector and a scalar?
A vector has both magnitude and direction, when scalar only has magnitude.
Exactly. 4 facts about the geostrophic wind. Actually, you should have. How many do you have? How many facts about the geostrophic wind should you have?
Was it 7?
7 or 8? Parallel to the isobars, upper level, linear, inertial, balance between the PGF and the Coriolis force. The speed is determined by the strength of the pressure gradient. They're directly proportional. It's inversely proportional to the spacing of the isobars. I don't know how many I listed off there. Might have been 7. Maybe there's an 8. Anybody have something different? I mean, this should all be in your notes, so I'm just assuming that it is.
Aaron said it's only true in the upper atmosphere.
It is definitely only upper atmosphere. Okay, Newton's 3 laws of motion. You need to write them out. I'm not going to go through that since it should be in your sheets, right? But the key thing is when I'm looking at the second law of motion, F equals ma is acceptable. That would be acceptable that you know that. Okay. What is the initial velocity of a ball dropped from rest? That's pretty easy.
0.
0. 0 what though?
Meters per
0
second.
meters per second.
Without saying meters per second, it's half up, right? What's the initial acceleration?
It'd be 10 meters per second squared.
10 meters per second squared. In other words, if the acceleration versus time is plotted out, then this graph becomes a straight line, right? So keep that in mind. What's the velocity at 4 seconds? Well, the velocity is increasing linearly. So if it starts at 0, 10, 20, 30, 40. 40 what? Meters per second. And then the distance, you need the average velocity, which is 0 and 40 divided by 2, 20 times 4 seconds. So the answer should be 80 meters. Okay, I gave you just the one. And remember that the x versus t is exponential. Because the object is going faster and faster, which means it will go a greater distance in the same amount of time. Here's a second, it goes that far, delta x. Here's a second later on, and it's going to go a greater distance later, because that way is later. Does that make sense? Questions, comments? All right. Now the short answer, or the little guys here. What's the formula for average velocity?
Change in x over change in time
Right.
equals velocity av.
That's velocity average. And if it's instantaneous, it's dx dt. That is at a point instantaneous. That is between 2 points average. Unit of acceleration
Meters per second.
for acceleration. What did you say?
What was it, meters per second?
That's the speed.
Oh, okay.
It's a meter per second, or meters per
Yeah.
second.
That's good.
A force acting perpendicular to an object's motion changes its,
Direction,
and when it's parallel, it changes its
speed.
speed, and direction is the velocity. So a velocity changes either speed or direction or both. Okay. Winds are subgeostrophic in a what? What did you say?
A trough.
In a trough, right? You could have said in a cyclone, right? But in a trough, that's the idea, because it is cyclonic. A force acting toward the center is centripetal force, and we talked about that earlier. True or false? Winds on the synoptic scale travel from high to low pressure. Do you say true or false, Nina?
I said true.
True.
No, false. Remember, on the synoptic scale, they want to. That's the pressure gradient force. They want to. But instead of going from high to low pressure, the winds get turned to the right because of the Coriolis force. So on the synoptic scale, the Coriolis force is important. So the answer to this is false. Does that make sense?
Mm-hmm.
Okay. In hydrostatic balance, the vertical, what's the forces, the vertical
The vertical gravity.
gravity equals what? Well, the vertical,
But the vertical balance of the forces of PGF and gravity causes thickness relation.
you could just say PGF, right? So remember, there's an upward force, it's pressure gradient force, but the formula for the pressure gradient force is -1 over rho dp
dx. Or
Not
dz.
dz equals gravity, and that's the hydrostatic. Okay. And then the Coriolis force is important in mesoscale events. And the answer is no. We can neglect them. A long wave is, right, there's actually two different answers for this. What are the two different answers for this question? Ryan?
A long wave is low frequency, while a short wave is high frequency.
Yeah, it's not what I was looking for. Although I know why you said that, but that's not meteorological.
I
Well,
said
the first answer I put is that a long wave is global and the
Okay.
short wave is synoptic.
A long wave is a global scale, short wave is synoptic scale, right? So that would be one of the two that you would put. What's the other one?
I put meridian and zonal.
No, because waves, when the jet stream is this way, it's meridianal. When these are still waves, but it's mostly zonal. What's the other answer? Long wave is what?
be waspy.
A short wave is baroclinic. This is super important that you know that. Remember, a baroclinic wave has temperature advection. Temperature advection causes a wave to modify. Amplify is the one that we drew a picture of. You could dampen it, de-amplify, dampen. But baroclinic is what makes these waves big. Sam, we were talking about that in 11 and 15. We said baroclinic waves, small disturbances amplify.
Yep.
That's baroclinic. That's all a result. Baroclinic means temperature advection. And that means waves modify. Super, super, super important on that. Okay. And then divergence is found.
Upwind of a trough.
No, not an upwind.
I put in the upper level of the atmosphere.
I don't know if I gave you enough room. Divergence is found downwind of an upper level trough, but cyclogenesis is found where only? An upper level shortwave trough. Okay. So anytime you have a wave, downwind of the trough is going to be divergent. Downwind of an upper level shortwave is enough, and it's synoptic scale that it creates cyclogenesis. So I don't think this one was known well enough by you, but you need to know that. Does that make sense to you? Aaron, you good with that?
Yeah.
Okay. And then a couple more. A storm that intensifies as it moves northeast to off the US Atlantic coast is called a nor'easter. A winter storm that affects us as it moves northwest to southeast is an Alberta clipper. And one that moves from Texas, Oklahoma panhandle is a panhandle hooker. We've already drawn these earlier. 5 facts about inertial motion. There are 5. What are they? Julia, did you have those 5?
I didn't have them.
What'd you say?
I didn't get them.
Shannon, what did you get for those 5?
The first one I got that there is no absolute force included.
No, what do you mean there's no absolute force? That's not the right word. Isaac, what did you write down for this?
I don't think I got this question either.
Oh my gosh, this should have been in your notes. Lena, what is it?
I have that inertia is the tendency of an object to remain at rest or remain in motion.
No, that's not 5 facts. Net force is 0. And really, you should say net external. That's 1. Number 2 is it's linear. No change in direction. Oops. Speed is constant, and that means velocity is constant. So these two make this. And then because of this, we'd say it's non-accelerating. Which is this, right? These are all saying the same things, but you need to know how you can think about inertial motion. So anytime the net force is not zero, anytime it's curving, anytime it's changing its speed, its velocity is changing, and that's acceleration. Okay? And then the greater the temperature gradient, we did that. What is this that we're discussing here?
Thermal wind.
So those 5 things about the thermal wind. We've done those in class. Okay? Any questions on that? Okay. Now, the last thing I want to do, all I want to do is have some fun. I'm going to show you a map of the future. So there's the jet stream now. Where's, gosh, Epic Pen. Okay, I got to figure out a way to do this. Hold on. Let me do it this way. Close. It's got to be in here someplace. Let's try it now. There's a thread stuck in memory someplace. There we go. Now it's working. So here's the jet stream. What does that tell you for us?
It'd be overcast.
Not necessarily. I mean, it's not overcast. This is current.
Wouldn't it be that the cold is to the north and the warmest to the
Right.
south?
So this is relatively cool. Now it's the coldest air is probably here because look at the strength of the jet stream over here. That must be a strong gradient because it's really fast. Over here, it's not as much, but it is definitely cool air, right? Our average temperature right now is, I think, we do this.
I think it's been like the 50s or 60s right now, so.
We had 3 days in a row at DuPage, it was a record low. But if I go to we've done this before. See, on yesterday, it went down to 30 degrees. Last night was 34 degrees. The normal low is 47. The normal high, look at this. The normal high is 70 degrees. And we're definitely not at 70. It's just we've been really below normal for a long time. So we still have that cool air in place. Not super cold. Notice that if this is where the trough is, this is all kind of convergent. So it's basically high pressure. And let me show you here on a satellite page how clear it is over most of the country. Right? Most of the country is clear, a little bit over here. Well, what do you think is causing those clouds? If I look at this thing called vorticity, then it'd be here. I see this big thing here. This big thing right there is a shortwave. That's the shortwave trough. So ahead of the shortwave trough in Minnesota, I've got some clouds, maybe some showers and thunderstorms. Okay, so what's going to happen as we go into the future a little bit? The shortwave comes through, we have a chance for rain again, kind of cloudy over here. But now watch what happens as we go into the future. Where's the main jet stream? The main jet stream is out here. Which means, generally speaking, what's all this air going to be? Right? Generally speaking, it's going to be warm, except I have a little bit of a trough here. I've got a shortwave trough. So I'm looking at an area where this might be thunderstorms. I have a problem here. Well, if that's the case, and Sam, this is what we were talking about, moisture will come in here, but it won't probably get to the north very well. But this overall is going to be warm based on the jet stream, based on the thermal wind. So I can show you one other thing here. These are what we call the temperature anomalies. How different than normal. And notice that I've got this really big area up here of much warmer than normal. This is really extreme warmth because where's the jet stream? Remember where the jet stream was? The jet stream is up here. And that's where the air is going to be super warm. But because I have a jet stream here, this area is probably going to be somewhat cold. And that's where the air is cold. So where we're a little bit in the warmer conditions, that's as of Tuesday. So our temperatures next week are supposed to be 70s. And that means we're going to be above normal because the normal high is only 70. So getting into the 70s puts us a little bit above normal. Okay. Let's go on a little bit further, getting into speculation land now. See that some winds come in like this? What I really have is I've got this wave right here. It's a short wave, but it's going to the north. The main jet stream is way up here. So again, super warm air here, but we have a disturbance and a disturbance. We have short waves coming through, not necessarily in the jet stream. It's kind of a weird pattern. Then we go forward at a time. And then if we look at this, now what do we see? We see a jet stream that's here, like that. So what does this mean for us, generally speaking? Warm.
Warm.
Except there's a little upper level low there. There's still these little upper lows. But for the most part, this should be warm. And if I go to temperature anomalies, I see a great area all above normal. So we're getting into definitely a warm thing. But I like the fact that there is a trough out here. So where will the action get more exciting?
On right entrance region.
Right? Right? Well, no, don't think of that in the pattern like this. This is where we be downwind of the trough. So that's where things might be interesting if this is true. I don't know if it's true, but if I'm going to be chasing, if I'm going to go chasing, then I want to be thinking where the winds are strong because I want vertical shear. So I'd be thinking, let me go into this color. I'd be thinking this area here is where I would be wanting to on Tuesday. Now the question is, what is the dew point? Well, the dew point's a little bit weak. This area here is where the 60s are. And so I've got this area here of moisture. And notice that the Midwest is getting into a lot of moisture. And Illinois and even Wisconsin are in the 60s starting next Wednesday. Our dew points start going into the 60s. Now that's going to feel completely different. Well, temperatures in the 60s, temperatures in the 70s, dew points in the 60s, it will feel like summer. You'll be running around in shorts. You won't even be thinking about frost or anything like that. The dew point currently, look at the dew point here now, 21. It's really dry outside. So even though it gets nice today, what's the temperature going to do tonight? Drop. Diurnal variation of temperatures drop because it's dry. You're going to get overnight lows. But by the time we get into next week, we're up in the 50s this weekend. And then by next week, we start to see 60s overtaking a big chunk of the area. So Colorado might be interesting, but if I were looking at someplace for severe, I might have to think going up on Tuesday to North Dakota, South Dakota, somewhere over here. So I'll take a sounding.
Only it was on the 28th. That's when I'm going out for a week to start a week-long chase.
Look at this. This is pretty good. This is Cape. How much is the Cape here? 2,000. The shear is 42 knots. That's enough for supercells. So here's soundings like this create supercells, and they create, some of them have been significant tornadoes, meaning EF, enhanced Fujita scale 2, strong tornadoes. And these are the days and times that had that. And hail, not so great. But there's definitely the potential for tornadoes. So for me, if this were right, I would be thinking underneath the jet stream, if this is right, go out into northern South Dakota, southern North Dakota, which is not, I'd rather be in Texas, but beggars can't be choosers. And that's a good place to be. That's too far in advance. I'm just saying that now. But the jet stream looks interesting.
This one for zonal.
This one looks this way. And then this one is here in the New Mexico because I have a big upper level low. So the weird thing about all of this is that the jet stream tends to be strong up to the north. It's displaced far to the north, except for these weird areas of low pressure that kind of move across.
Is that a thermal low?
No, that's an upper level low. Thermal lows are at the surface.
Oh.
So given the proximity of this area on that following weekend, it's one of those things where I might need to look out for what's going on up in the high plains. And if this gets a little bit better, I'll definitely go. So my guess is I'm probably going to do this kind of a trip. I'm going to come over here. I'm going to go across to Kansas City because there's a restaurant I want to go to. And then I'll chase over here for a day, take a couple days off, and then get up here, chase around here for a while, and then later in the week move down to here and then come home. Now, this is way too far in advance, but when I do storm chasing, and what I will do every day is I'll plan out what would I do? Where would I go? You want to practice that? Where would I be today? Where would I be tomorrow? And then every day do it. And if you start seeing over the course of a week, you're always at the same place, you have some confidence in that forecast. As you get closer, stay with your original forecast. this is way out in advance, so I can show you Cape. Here's just all the Cape for the next 2 weeks. And this is when I'm going. So there's this weekend looks really good, or Monday into Texas, Tuesday, then it takes a while. Maybe up into Kansas on Thursday. Friday doesn't look that good. Saturday, don't know. It doesn't look that good as of now, so I may not even go out the first weekend. But then I start to see this coming in here Monday, and I might want to try someplace out in Wyoming. Yeah, marginal severe. That's where I like on Tuesday, Wednesday, a little bit less, but it might be worth getting out there for a day. And then we'll see, because it doesn't even look that good anywhere in the future.
Yes. Oh, sorry. Obstruction.
That'll change.
Well, of course it will. How many years have we been forecasting, Sam? How many years of spring have I had?
I only started attempting to forecast beginning of last year.
Okay, so I only have 20 times more experience.
Yeah, I know, but remember, I did nail that.
Well, I know that's because the models are really good, but when you start going interpretation, you'll have to trust me more. I got a lot more experience. Anyway, but you get to see where the jet stream is. You get to see how the moisture, instability. So all of those things get put together. So I hope that you guys can maybe take another class. Lena, I think I'm going to see you doing something at least a couple times, and in the classroom.
Yeah.
Although I'm not sure if I have any classes in fall that are in class. I have intro and severe in class, but then in the spring,
Okay.
I'll probably be in class with forecasting and maybe storm chasing. You gonna go storm chasing, Lena?
Okay. I
think-
want to. My uncle does, so
Well, go with your uncle. You both can take it.
yeah.
How about the rest of you? Will I see you in any other classes?
Probably.
Well, Sam. What's your major, Shannon?
Oh, I don't have one. I'm just general studies. Yeah.
Well, maybe you should go into meteorology.
Mm.
What are you doing, Julia? What's your major? Oops, you have no mic. Aaron, I know that you're a literature major, English major, writing your children's books.
Right.
You could do a tornado book on a book of weather for the kids. Julie, what'd you say? Is it working yet? Oh, it's not there. I can't get you. Zach, I know your major's in computer. Isaac, what'd you say yours was?
Wildlife conservation and ecology.
Are you going to do anything with forest fires?
I'm not sure.
No, that 1119 might be a good course for you if you want to do something. You'd probably do well in that course. Ryan, what's yours major?
Welding.
Welding.
Yes.
I've had a couple of really great students who have been welders. So I don't know. I like welding students. Anyway, that is the end of class. I think what's happening is my test will be available. Well, here, hold on. I don't need to share the screen. Let me just look at this here. Blackboard 1110.
Will the exam be available
The test, let me see.
or the final?
So basically the test is available today at 3 o'clock.
All right.
There's a written and test portion is like usual.
No, it is all multiple choice.
Okay.
And when is it due? It's due. When do you want to do? We'll make it due.
Is it timed?
How about Monday by midnight?
Yeah.
I think that should give you enough time over the weekend.
Will it
And
be
it's
timed?
not, it is, I'm looking at it now. It is 17th. What day is the 17th?
That's Monday.
That's Monday. Okay, so let me- there's no timer. You just turn it in once though.
Can you start and then stop it again and then
Yes.
re-go back to it?
Yeah, there's
Okay.
yeah, you can do that. Just don't submit it, okay?
Mm-hmm.
And when I look at your grades and everything, so this is, I think it's 120 points. So it's worth something. Okay. And then I'll have, once I'm done on Monday, I'll have your grades by Tuesday. Okay, so take off a little time. You can do some studying. Do a couple hours of studying before you take it. But certainly because I'm doing it untimed for the final, you can take some time and do well on it. That would be a good thing. All right, save your grade. If there's anything else, like Julia, I got your notes from the other day, so I'll put that into your thing. So all of your grades will be in later. And then if you have anything else that's left over, turn it back in, okay?
So do you want us to turn our Unit 4 notes in by tonight?
Yeah, turn your Unit 4 notes in. Okay, because I'm not going to do any grading until Monday. But on Monday, everything's going to go in. Okay?
Mhm.
Everybody
Can I
good?
talk to you after class?
Sure thing, Sam. The rest of you, it was great to know you. I hope to see you sometime. Stop in and see me. If you have any questions, email me. But I hope you have a great life, great summer. Good to have you here, guys.
Hey, thank you.
Thank
you.
you.
Bye.
Thank you. Have a good